Thank you, dear. I'm just going to double check to make sure I got put in. Sweet. Ooh, my eyes coming too. Love it. All right, so this spell work, it looks a little funny, but this is, I promise, something we can do. This is just order of operations done in kind of a weird way. It's just bunched weird. But I promise this is easy. Not just being weird for weird's sake. So that is a valid thought. So on this first one, if I have 2 minus 3x plus 5 plus x, are these parentheses actually doing anything for me?
No.
On these one? Oop.
Not really.
Not really. So, I'll zoom that back out. This is the same exact thing as if I just had these without the parentheses. 2 minus 3x plus 5 plus x. Same thing. The parentheses aren't really doing much. So, all I gotta do is combine some like terms. I've got 2 plus 5, 7. And I have minus 3, x plus x. What is that squiggle? If I have minus 3x plus x, minus 2x. And we can write it as 7 minus 2x, but it feels a little bit weird. We're going to be a little bit more used to writing it as minus 2x plus 7. I only write it this way because it's getting us ready for what we're about to do today. Oh, snap. On this second one, are my parentheses doing anything? Do we need to do anything special with our parentheses? Yeah. This first one, nothing much. Like nothing's really happening here. But I've got a minus sign. So I need to make sure we subtract the 6 and we subtract the 4x. We got to subtract the whole group. So when we take this piece out of the parentheses, we're going to have our 7 minus 3x is just hanging out. Then we need to make sure we're going to subtract the 6 and subtract the 4x. I distributed that minus sign through. We got to make sure we subtract both pieces. We're subtracting the whole chunk.
The whole chunk.
The whole chunk. He's chunky. So when we combine our like terms, what do we get?
1 minus 7x.
Mm-hmm. So my 7 minus 6 and my minus 3x minus 4x. So we're at minus 7x. Or, because it's x's and feels weird, minus 7x plus 1. It does not matter to me. Like, we can leave it in either direction. You did the part that was important. Questions on those two pieces? Because I know they're a little weird and they felt really awkward. But I promise it's for a reason. Okay, let's look at number 3 then. This is what we did yesterday. So how are we going to simplify the square root of negative 12? What do I need to do with this guy? Yeah, we're going to break this up into pieces that are easier to deal with because the minus 1 is kind of gross. So we're going to have our minus 1 times, and how should I break my 12 up so that I can something that I take a perfect square of? What is a factor of 12 that is also a perfect square?
4.
4. I can write 12 as 4 times 3, or as 3 times 4. I'm going to do 4 times 3. I don't know why I did 4. There we go. That's an order I like better. Because if I break it up into factors like that, then I can break them up into separate radicals. we can have our square root of -1 times our square root of 4 times our square root of 3. What is the square root of 4?
2.
2. Can we simplify the square root of 3?
No.
No. Icky decimal grossness. What is the square root of -1? I. That's that guy we talked about yesterday. This is our I, that imaginary number. Makes it not real.
For some reason.
Because mathematicians are a little bit extra. And it bothered them they couldn't finish their stuff. Legitimately, that's why they made those. Is because they couldn't finish solving problems and they got stuck and they were mad. That's where it came from. They were irked. Because
They had a grudge for absolutely no reason.
well, imagine being that bored.
Yeah.
Imagine being that bored in the pre-internet days that not being able to finish your math problems bothers you that much to invent a whole new concept about it. I mean, to be fair, imagine being bored enough in the pre-internet days to invent calculus.
Hell.
They didn't have internet, so we did math problems all day. Why not? Got nothing better to do. Okay. Questions on these bits? Okie dokie. So what I'm going to put up here is going to have like, we're going to have a definition, and then I'm going to have a picture, and then we're going to get into problems. You don't have to do much like with the definition. I'm just going to talk to you about it to give you the name of what we're talking about today. Because what we're talking about today is something called a complex number. We've dealt with real numbers. We've dealt with imaginary numbers. Today we're going to take them and we're going to smush them together. That's all it is. Really, the only important part in here that we're going to use is that they look like this. It says a number plus b times I. So a plus b times I, which just means we're going to have a real number, some real number, like 7, 12, -3. Some number. We just call it a because it's in front. And we're going to add or subtract some imaginary number. 2i, -7i, 3i, 1/2 I. Imaginary number. b times I. And that is magically called a complex number. That is what that is. We put them in parentheses just to say this is a chunk. We're going to talk about this guy as a unit. That is the complex number is the unit a plus bi. The rest of this definition, honestly, I didn't use until I got to grad school. So just say our complex number is the parentheses thingy that looks like that. But that looks awfully similar to some chunks we had in the bell work. We just had them with X's in the bell work. Oh my gosh, they're really similar structure. What? Almost like I was intentional with stuff. So these complex numbers come from when we smash together real numbers and imaginary numbers. So it is not inside the real numbers, nor is it inside the imaginary numbers. This is in a weird part of the mathematical universe outside of both boxes. So if you remember way back in the day when we talked about, like, we would have integers, which was our smallest possible unit, and then we'd have our whole numbers, and then we'd have our irrational numbers, those kind of sets, talking about those way back in the day with our different kinds of numbers, like 6th, 7th, 8th grade. That's what this thing is going to start to look like now. This is the sets we normally live in the world of integers and whole numbers, all those things, like our rational numbers, our irrational numbers. Our imaginary numbers are purely outside of that. They're not real anymore. And then the complex numbers are outside even both of those. It's where they're both out here. The big box outside is where the complex numbers are. You do not have to know anything else about this picture. I'm just trying to give us a little context. This is outside the real numbers. We're not in the world of real things anymore. It's all pretend. It's like a Halloween costume. It's just for pretend. So what we're going to do with this is we're going to take complex numbers and add and subtract them. So I've got a complex number, 2 plus 3i, and a complex number, 5 minus I, and we're going to add them together. This is very, very similar to some stuff we did in the bell work. And in fact, we treat it exactly the same way we did the things in the bell work. Because if we had a problem that was 2 plus 3x and 5 minus x, what would we do? Just combine our like terms. It's the same thing when they're complex. It's the exact same thing. We combine our like terms. So the parentheses in our addition aren't really doing anything for us. So this is the same thing as having 2 plus 3i plus 5 minus I. And we're going to come through here to combine some like terms. What like terms do we have? Our 2 and our 5. It's going to give us 7. And then we have our 3i minus I. What are we going to have there? Positive 2i. And that is the answer.
This is surprisingly easy.
I was going to say, the hardest part is figuring out I.
I am concerned.
What I is the most annoying part of it. We get a little scared when we see them. But it's not bad to add or subtract them. Finding out where they are is weird, but like this is, it's not awful, I promise. We are not always awfully mean. So here's another one. This one's straight up from the textbook. Where is that mark coming from? It is not on my iPad. That's like straight up, that mark in the middle is not here. Ha! Found it. I'll color it over with white. All right, so here's another one. I've got the complex number 8 plus 3i and the complex number 4 minus 10i, and we're asked to subtract them. With this one. What's up?
Do you have a paper towel or something?
About knee high right here. I also have a first aid bin right there because it looks like you might be Band-Aid needing. There's alcohol wipes in there too with Alfred. Like to dig them. All right. So when we're asked to subtract, we did one very similar to this in the bell work. What am I going to need to do? Distribute my minus sign through. So my first number is not going to change. We're still going to have our 8 plus 3i. But back here, I need to distribute this minus sign to both pieces. We're subtracting the whole chunk. So we're going to have minus, bless you, 4. And minus negative 10, minus negative, going to become a plus 10i. So the minus signs, you need to make sure you are distributing those through. Really important. Oh, boo, my water's empty. Now we're going to do our combined like terms the same way we did before. So what like terms do we have? 8 minus 4. So we're going to have 4. And then we have our 3i plus 10i. So we have a positive 13i. Okay. Questions on that one? They're weird, and again, honestly, the hardest part is wrapping our brains around I. What's up? Oh, I thought you said question. Awesome. It's called I'm old, and last night was stressful. What's up?
Is there something in the napkin?
Yep.
Did you get a award yesterday?
Yep.
It looks nice.
Yep. We all look like my mom, which means we all look like my grandpa. All of us. This is his face. My sister's 8 years older than me, and we got mistaken for twins for years and years and years. apart. And it's kind of terrifying, and I hear her come out of my face sometimes. I hear her voice. I'm like, oh, that was my sister.
Are your voices at least different?
Not really. Our attitudes are different, but like, no. It's terrifying how similar we are sometimes. All right. Let's do another one. So we're going to simplify this. What do we need to do here? Distribute the minus sign. Good. So I need to take this minus sign and distribute it to my whole second piece. So we're going to have our minus 5 plus 5i. And we need to subtract negative 3. Minus negative 3 means it's going to be plus 3. But minus 8i. So what are we going to get when we combine these together?
Negative 2.
Negative 2. It's coming from my minus 5 and my positive 3.
Minus 3i.
Correct.
I did that one.
You sure did. My plus 5i and my minus 8i gives me minus 3i. Okay? So, not awful. Right? So adding, subtracting, we can do this. We just get scared because there's i's. I promise they're not bad. Slightly more complicated will be, instead of adding and subtracting, when we get into multiplying.
No.
Yes, you can. I promise you can. I promise you can. Whether you like to box multiply or distribute, works the exact same way. There's just one little chunk we're going to remember from yesterday.
My brain can't process this right now.
To be fair, this is the last page.
Good. Because I'm already stressed enough with tech weeks.
Well, I was in the battle for tickets last night, so I did not win. And almost got scammed, but I didn't.
What?
Almost got scammed from a friend of a friend. They tried real hard. Do you have to send them $2,000? All right. So, if you like to box multiply, 100% works. I know it's becoming less and less like popular, but it totally works. Ooh. When you do our multiplication, like this guy,
Oh, yeah.
this guy back in the day, if you want to do our 5 plus I times 3 minus 6i, that 100% is going to work. 100% will work. You can also do this distribution style where I take my 3 times the 5. What is 3 times 5?
15.
15.
I don't know why I did that.
Same thing we get up here. If I take my 3 times I, what's 3 times I?
3i.
3i. Woohoo! I ask hard questions sometimes. So we have plus 3i. We take our minus 6i times 5. What might minus 6i times 5 be? Negative 30i. Good. Negative 30i. It's the same thing up here in the box.
Minus 3i.
And we have one last piece. Yeah, our minus 6i times I, we get minus 6i squared.
Oh, yeah.
So if you do the box, remember when you pull everything out of the box, you add them together, you wind up with this exact line of values. So whichever way you get to it, whether you do the distribution or whether you do the box, you get the same pieces. 100% works either way. You do not have to do both ways like I did up here. But both ways work. So whichever one works better for your brain, whichever one you look at and don't go, ugh, do that. But I know so one of those you're gonna look at and you go, ick. I get it. All right, so now we're looking at this and we're gonna try and do some simplification here. What can I simplify in this bit? The 3i and the minus 30i. So I've got my 15. What do we get when we combine those together?
27i.
Minus 27i, so negative 27. And then we have this minus 6i squared. We talked about I squared yesterday. Just a touch.
That equals -1.
It does equal -1 because remember I'm not going to go through it again. Our I, that's the square root of -1. So if we have I squared, that's the square root of -1 squared, and my square root cancel out. So our I squared actually equals -1. So it's not minus 6i squared, it's minus 6 times -1. Oop. I'm going to write that out.
So that would be 6 being added to the 15.
So minus 6 times -1. So it becomes a plus 6. And well, then I can combine my like terms again. This becomes 15 minus 27i plus 6. So what do I get when I finish my simplifying step here?
21 minus 27i.
Ding! 21 minus 27i. When we multiply complex numbers together, we will get a complex number, a real number, or imaginary number. We should not have exponents in it still. It should be a number. This might be weird looking. All right, let's do the one on the right. Very similar vibe. Again, you can box it, you can distribute it. If you have another method you like to do for multiplying, more power to you. We're just going to multiply these together. So we're going to take our 2 plus 3i times our 2 minus 3i. Again, I'll do both methods just so we have it for whichever way you like to multiply. So I'm going to take my 2 plus 3i and my 2 minus 3i. And when we're looking at doing this multiplication, we're going to do our 2 times 2. What do we get with 2 times 2?
4.
I know, I ask such hard questions sometimes. Oh my goodness. We're going to have our 2 times minus 3i. Minus 6i. I'm in the wrong box over here. There we go. If I take my 3i times 2, positive 6i, good. And then our last one is our 3i times minus 3i, negative 9i squared. Negative 9i squared. So what can we do up here next? Combine our like terms. What can we do to combine like terms here?
It'll be 0.
We'll have no i's. 6i and negative 6i, those are going to cancel out. What else can we simplify over here? Our I squared, we know this guy equals -1. And that this guy was going to simplify down to be 0. So this is going to become 4, minus 9 times minus 1 gives me plus 9. So our answer here is 13. I was in the fight last night for tickets tonight. I lost repeatedly. Okay. So our complex numbers and our imaginary numbers are weird looking and scary, and I promise they're not as bad as the first day makes them seem. tonight, tomorrow, and Sunday. Only go downtown if you have to, because it's going to be absolute insanity. Because the Taylor Swift concert this weekend? I mean, all three of them?
When did she get into town?
Probably yesterday. Because they're building the stage since Tuesday.
Because I haven't seen anything about it.
Oh, she's very sneaky when she's actually in the town, because she would absolutely get mobbed.
But
Absolutely.
It's funny because I think she correlates her schedule with the NFL because
Sometimes.
she uses a lot of their stadiums.
Oh, they have to they have to work together.
Yeah. So yeah, I legit saw a commercial for the Colts playing at the Vikings this weekend.
Oh yeah, they're away. Yeah, it's an away game this weekend. Well, my favorite thing is that the stadium from New Orleans actually sent their giant inflatable friendship bracelet to Indy, so the stadiums are trading friendship bracelets now.
Oh my god, that is so cute.
Oh my gosh.
Did you see that they put like friendship bracelets on the dinosaurs outside of the children's museum?
Oh yes. The amount of friendship bracelets I have in my car to take downtown tonight is absolutely insane. Like, it's a problem.
Jealous.
All right. Well, I'm not going. I'm just going downtown to the merch tent and to wander downtown and find all the decorations and stuff with my 10-year-old.
I know.
All right. So we are going to do a little quick exit ticket thingy. Oh, yay. You can use your notes if you want to. I'm also going to pass back all you guys' homework while you're doing it.
I forgot we had a skills check today.
It is very short. Very short. Single sign. There are technically, like, 2 questions. Well, actually, no, it's all based on one thing. So it's basically one question, just with lots of little bitty parts. Okay?
You mean there's multiple parts? Like A, B, and C, and D? and
Yes,
D?
but it's all based off the same equation. All right? So,
It's okay. That makes no sense, but so much sense at the same time.
love it.
Oh.
So it's all the things we've done, like since we started this chapter, except for the complex stuff because we just did that today. This is one of those things where I grade every question in it, and I will give you the feedback on that because on the homework I only grade some of the questions. What's up? What's up? Yeah, it goes in his cycle homework. But I grade every question on it. Most of the homework, I don't grade every question.
Yes, this is general. Why did I put 6 instead of a B? That makes no sense.
Just,